Hey, Smath here, bonding video number 4. This time we're going to talk about molecular polarity. We've already talked about bond polarity. That's a separation of charge in a bond due to differences in electronegativity. Molecules can be polar or nonpolar based on how many bonds and how many lone pairs, how they're arranged. Now the only way to really know this is to look at the Lewis structure. But let's look at a couple of examples of how to determine molecular polarity. If there's one bond in a molecule, then that bond type is going to equal the molecule type. Let me show you here with HCl. I have H going to Cl, bing, bing, bing. This has an electronegativity of 2,1, 3,0. The bond is polar, so you got a polar bond. And in this case, because there's only one bond, the molecule is polar. So molecule is polar as well. What about O2? We haven't really drawn this structure. O2 is very interesting. It forms a double bond. But it's still only one bond. It just is sharing 4 electrons instead of sharing 2 electrons. Well, if we determine the bond type, it's bonded to itself, so the electronegativity has to be 0. This is a nonpolar bond, and because of that, it is a nonpolar molecule as well. So it can be either polar or nonpolar. One bond, the bond type is the molecule type. Now, number 2 says lone pairs on the central atom can make a molecule polar. Not only can, will make a molecule polar. So let's look at NH3. N goes in the middle, 3 oxygens on the outside, and I have a lone pair. That lone pair makes it polar. 1 lone pair, 2 lone pairs, doesn't matter. Lone pairs on the central make molecules polar. Water does the same thing. If we draw this out, we're going to take an H to an O to an H, excuse my back, and there. I've got 2 lone pairs on that central. Doesn't matter. It's still going to be polar because what I've got with this molecule of water is lone pairs on the top, atoms on the bottom. The whole top side of this molecule is going to be very negative, very polar. When I say polar, I mean negative compared to positive. Those are the poles we're talking about. The last rule I have is dipole interactions. If the dipole cancels, then the molecule is nonpolar. If the dipole doesn't cancel, then it's not nonpolar. So if we look at MgBr2, Steve, put the Br out there. Give the Br its lone pairs. Now, my electronegativity for this one is 1.2 and 2.6. So my dipoles are arrows that show electron movement towards the higher electronegativity. So in this case, I have a tug of war going outside. These dipoles are going to cancel. This is a nonpolar molecule. It may have very polar bonds due to this difference in electronegativity, but because those pole of electrons cancel out, that's nonpolar. AlCl3 does the same thing, where we put Al in the middle and we make a little peace sign out of it, put our chlorines around it. My bond difference is 1.5. I've got a very polar bond, and this is 3,0 and this is 1.5. So the pole of our dipoles are all going out. They can go out, they can go in, they can cancel in any direction. But because this is equivalent, everything cancels out nice and neat. This is another case where you have a polar bond and you have a nonpolar molecule. Nonpolar molecule with a polar bond. Now CH3Cl does it very similar. I'm going to put carbon in the middle. I'm going to put 3 H's and a Cl. And if I look on my electronegativities, I find out hydrogen is 2,1, carbon is 2,5, and chlorine is 3,0. So the pull of electrons there, push, push, push. Because the hydrogens are lower than the carbon's drawing the hydrogen electrons in, and the chlorine's pulling the carbon's electrons out. This whole molecule is going to become very polarizable. So we have, once again, a polar molecule, and in this case we have all polar bonds. Molecule polarity is probably the hardest topic that we tackle in first-year chemistry and even in AP chemistry, because you have to be able to draw the structure and see the pull of electrons. It's pretty simple once you get the Lewis structures up, but they're kind of hard to draw in the first place. I understand this is a tough topic, takes a lot of practice. Just give it a shot. I think with a little practice you'll get better at it. I'm Smath. I hope this video helped you.